Hey guys, welcome to the lesson on solving with complex numbers. So again, we always start with a do now or a simple little warm up. Let's go ahead and evaluate these values or simplify these values. So let's start with the square root of -1. So like we reviewed in the previous lesson, the square root of -1 is actually just I. So if we were to use our product property, we can break this down into -1 times -36, which in turn just gives us I 6, or in standard form 6i. And our last one would be the same concept. It'd be -1 times times 16 times 2. So again, square root of -1 is just I, square root of 16 is 4, and root 2 stays exactly the same as root 2. Let me go ahead and make that look like a 4. And in standard form, again, we get 4i root 2. Boom. Alright guys, so that's our quick little warm-up. The lesson again is graphing and solving with complex numbers. So our objective for this lesson is giving an understanding of adding, subtracting, and multiplying complex numbers. Those are the operations we did on the previous lesson. Students will solve quadratics with imaginary solutions. So our actual objective, or what we're working on, is students will solve quadratic equations with complex solutions or imaginary solutions, complex solutions. Let's go ahead and look at how to graph this. So again, instead of our Cartesian plane and our x and y axis, we're actually going to label this reals for all my reals and imaginary for all my imaginaries. Actually, let me color code it. We'll do the imaginaries in red. So if I list out my actual values, I'm going to go from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Same thing on my negative line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 10. My imaginary values, I'm going to have 1i, 2i, 3i, 4i, 5i, 6i, 7i, 8i, 9i, 10i. Same thing with my negatives. 1, 2, 3, 4, 5 or negative 5i, 6, 7, 8, 9, 10, negative 10i. And I'm going to go ahead and begin with the first example. I'm going to plot my I. So remember that all numbers have two components to them. It has a real component and my imaginary component. So this is purely imaginary and it's at 1i. So 1i is actually just there. That is considered to be plotted. Done. Let's take a look at the next one. My real component is 5, but my imaginary component is negative 3i. Or I should write my imaginary component. So we're going to go ahead and plot that as well. So my 5, here's positive 5, and then imaginary part, I'm going to go down 3. 1, 2, 3. So this would be my point if it stays. Alright, so that's going to be it's positive 5 minus 3i. Let's go ahead and graph these other three examples. So we have negative 3 plus 2i, so that's going to go negative 3 plus 2i, that's positive 2i, that's up here. So that's going to be negative 3 plus 2i. We're going to plot 4, that's just completely real, so that's right there. That's just 4. Add the last one, negative 4, negative 10. So here's negative 4. We're going to drop all the way down to negative 10, which is there, and label it negative 10i. So that's just how we would plot these imaginary or these complex numbers. So now let's move on to the solving portion of it. Again, you can use any single method to solve. Let's go ahead and look at this. Let's go ahead and subtract, or set this equal to 0. Subtract 11 to both sides. When we do so, this goes away. I'm left with 2x squared is equal to negative 48. If I divide both sides by 2, this goes away. I'm left with x squared is equal to negative 24. Again, this is going to just be the factor method, or the square root method, I'm sorry. My squared and my radical go away. When that goes away, I get this plus or minus on my right-hand side. So really what I'm left with is negative plus or minus the square root of negative 24. This can be factored out to plus or minus the square root. So this now just becomes an example like I do now. This is just negative 1 times 4 times 6. And that always keeps looking like a 9. I don't know why. 4. So if we continue using our product rule, we can go ahead and just say, well, that's just the square root of negative 1 times square root of 4 times square root of 6. Keep simplifying. We get I. Square root of 4 is 2. And square root of 6 remains as square root of 6. In standard form, we get two solutions. X is going to equal our plus 2i root 6 and negative 2i root 6. And those become our two solutions. So as you can see, we just kind of took it to that extra level. So this lesson is really just using those previous methods and understanding how to obtain or solve with complex solutions. I'm going to go ahead and just work on the hardest, which would be the green level problem, just to give you guys another example. I'm going to rewrite it as negative 5 n minus 3 squared is equal to 10. So again, I'm going to have to solve for n. So if I want to solve for n, I'm going to divide both sides by negative 5. This goes away. I get n minus 3 squared is equal to negative 2. I'm going to square root both sides to cancel out that squared term. When I do that, this goes away and I get a plus or minus. So if I were to rewrite this equation, I get n minus 3 is equal to plus or minus the square root of negative 2. Well, that can be simplified to n minus 3 is equal to, again, we factor out that negative 1. We actually just get plus or minus I root 2. Now we add 3 to both sides to solve for n. This goes away. We know that we can't combine our real element with our imaginary element. In fact, in standard form, our real element goes in front, plus or minus our imaginary element. We obtain two solutions, 3 plus I root 2 and 3 minus I root 2. Dunskies. All right, let's take a look at example 3. Example 3 is going to be a bit more complicated because now we are definitely going to be dealing with the quadratic formula. So if we set this in standard or equal to standard form, we get minus 5, this goes away, negative x squared plus 4x minus 5 is equal to 0. In class, we went ahead and we showed how it did not work with the factoring method and some of the other methods. So when all else fails, the most reliable method is the quadratic formula. So just in case we got to go over that again, we have x is equal to, the negative boy was undecided to attend the radical party, and with a squared bouncer took away 4 alcoholic containers. The party was all over at 2A, leave off the M. So we're just going to plug in directly into that. So my A value in this case is negative 1, my B value is 4, and my C value is negative 5. I'm going to go ahead and write the quadratic formula, or write it as a shell, and then just plug in these values. It's negative B plus or minus the square root of B squared minus 4AC all over 2A. So again, I'm going to plug in just those values. Well, this is a B, this is a B, this is an A, this is a C, and this is an A. If I evaluate those out or simplify, I just get negative 4, and those 4s keep looking like 9s. Alright. So I'm going to get negative 4. Again, they look like a 9. Alright. Let's try that again. Negative 4, there we go, plus or minus the square root of 16. And then negative 4 times negative 1 is positive 4. Or positive 4 times negative 5 is negative 20, all over negative 2. So in that case, we're going to go ahead and keep simplifying. Negative 4 plus or minus the square root of negative 4, because we simplified or reduced or subtracted, all over negative 2. Let me bring this up here just to kind of show what's going to happen. If we evaluate one more time, we get negative 4 plus or minus square root of 4 is 2, but that negative gives me that I. So I'm going to end up with 2I over negative 2. At this point, we can go ahead and factor out a negative 2 from the top and reduce. Or we can just reduce this entire thing by a 2, meaning we're going to divide this by 2, and of course this is our dividend. So either method you choose is correct. So let me show you guys what would look like if you just factored out. So I'm gonna, let's factor out a 2, or better yet, let's factor out a negative 2, up to whatever. Here is my 2. If I factor out a 2 inside my parentheses, I'm going to be left with negative 2 plus or minus some I. And in my denominator, I'm left with negative 2. Or you know what, for argument's sake, sorry about this guys, don't hate me. For argument's sake, let's go ahead and factor out a negative 2, meaning I'm going to be left with a positive 2 inside plus or minus some negative I, all over negative 2. So my negative 2's will cancel out. When my negatives 2 cancel out, I get x is equal to 2 plus or minus this negative I. So if I rewrite my solutions out, I get 2 plus a negative I, 2 plus a negative I, and 2 minus a negative I. This just simplifies to 2 minus I and 2 plus I, my two solutions. So that's what makes it hard, is that final step of reducing. So again, you guys can pause and forward and go at your own pace as you like. So that pretty much wraps it up for this, guys. It was a short lesson, just 3 examples. I wanted to show you guys how to solve or what to do when you come across these imaginary solutions. Hope it helped. That is the last lesson in this unit. After this, we're done, guys. So hope this helps. See you next time.